Hello, students. I decided I'd take about 10 minutes and just do a short video about hypothesis testing because I know it can actually be pretty confusing to people what we mean when we say the null hypothesis and rejecting the hypothesis and so on. Okay, so today we're going to talk about hypothesis testing. Let's see if I can yeah. And then, in fact, we'll do this full screen. All right. So, hypothesis testing. Okay, now just think of a hypothesis as like a guess, okay? Let's say that we just wanted to guess that there was a relationship between two variables, like happiness and attractiveness, let's say. And we have the opinion that, based on the research that we read, that happiness is directly correlated with attractiveness. Then we would have, that would be our alternate hypothesis, would be basically happiness is correlated with attractiveness. Now, but the thing about science is we always have the null hypothesis, which is basically just think of it as being the status quo. Before we do our research and we don't really know the answer, then we would start with the idea that there is no relationship between our two variables. So the null hypothesis is that there's nothing there, no relationship, or later when we talk about ANOVAs and t-tests, no significant difference between groups. The alternate hypothesis is that there is something there that we are expecting to find when we do our research. Okay, so then I'm just going to show you guys this thing, and I'm sure you've seen it before. I know you have, because I've showed it to you many times, but this is the statistics decision tree. And so far in the class, we've talked about this half, the descriptives and the chi-square tests and the Spearman, Pearson, and we even talked about multiple regression a little bit. Let's start with the chi-square test for association. And we'll go to our data set for the class. And remember that chi-square test for association is when you want to see, is there a significant correlation between two nominal variables? So here we have, for example, let's just say, here, let me expand this a little. What is their political party, and are they friendly or cold? Okay. So we want to know, we want to construct a chi-square that will analyze whether there's a significant relationship between political party membership and friendly or cold. Now, what would be the null hypothesis in that analysis? Well, it's this. The null hypothesis is that there is no relationship between political party and friendliness. And then the alternate hypothesis in this analysis that I just started talking about would be that there is a significant relationship between political party and friendliness. Okay, so we run the analysis. Now, do you guys remember how to do this? When you're doing a chi-square test of associations, you go to descriptive statistics and crosstabs. Click on that, and then what are they? Political party in one row, and then friendly or cold in the other. and then you go to statistics and ask for a chi-square. And I always tell people to do this. Just click on expected so you see the expected. And then hit OK. So here comes our output. And what you can see here is that when it comes to friendliness, our Democrats are a little bit less friendly than we expected. We expected to see 16 people here, but actually we see 15. And then, but it's pretty close. Then over here, the Republicans, every single one of them is friendly, which is a pretty surprising outcome in my experience. I'm not saying that Republicans are unfriendly, but just I wouldn't say they're 100% friendly, and so on. Now, as you can see, the chi-square really measures the distance between these observed and expected counts. And so as you can see, even though this is seems like a big deal, it actually isn't, because when you compare 8 to 6.7, that's just 1.3 off, and same over here. And this is very close too. So, to decide if you're going to reject your null hypothesis, you look right there. And you compare that number, the significance level, to the number in your mind. I hope right now you're saying to the number 0.05. And if you were saying that, then yes, congratulations, you're correct. You compare it to 0.05. Now, if this is more than 0.05, you fail to reject the null. And what does that mean? If you fail to reject the null, that means that as far as you're concerned in this study that you've done, there is no relationship between friendliness and political party, because you failed to reject this null that says there's no relationship. Let's look at a different at a different analysis. Just going back to this tree for a minute, and we'll do a Spearman's row. So that means we're looking at two ordinal variables to see if they're correlated. And we go over here and look at our variables, and here's our ordinal variables. So let's just choose the one that I had talked about earlier, which is happiness is correlated with attractiveness, okay? So what we do is analyze, correlate, bivariate. Click on that, and then we get attractiveness and happiness into our analysis. And now remember, you unclick Pearson and click Spearman. Why do you do that? Because these are ordinal variables. If they were scale variables, then we would use Pearson and not Spearman. Okay. So, now, what is our null hypothesis? And I just want you to say it in your mind right now. What is the null for this analysis? The null is that there is no relationship between attractiveness and happiness. So I click on OK. Here comes our results, and our Spearman's row is 0.355, and to see if it's significant, we look at this 0.033 and we compare it to what number? 0.05. It's less than that, and that means we reject the null hypothesis. So let's take a look at our pad here, and so because P in this situation is less than 0.05, that means we reject the null. Okay? Which means that in our sample, there is a significant correlation between happiness and attractiveness. Okay, if you understood that, great, and if you didn't, then let's see if it'll sink in on this last one that we're going to do. Now we're going to turn to a Spearman correlation, go back to our data, and pick two scaled variables. Let's try salary and body mass index. Okay, so we go to Analyze, Correlate, Bivariate. Get rid of these two, and we're looking at salary and body mass index. We unclick Spearman, we click Pearson because these are scaled variables, and we hit OK. So our null hypothesis was what? Our null hypothesis was that there's no relationship between salary and BMI. The alternate hypothesis was that there is a relationship between salary and BMI. In this situation, our Pearson R is 0.048. But don't get confused, okay? This is the Pearson's R. The significance level is 0.781. We compare that number with 0.05. Because it's greater than 0.05, we fail to reject the null. So what that means is, I'll put it in blue, when P is greater than 0.05, we fail to reject the null. So what that means in our study that we just did is that there is no significant relationship between salary and BMI in the study that we just did. And why do I say that? Because when we look at our output, the significance is greater than 0.05, so we fail to reject the null. And sometimes people get confused when I say fail to reject or do not reject, because it is a double negative. So for a lot of people, it's much easier to say when this is greater than 0.05, we accept the null. Accept the null is not really good science to say that, because we don't accept anything because we're scientists. So it's more proper to say fail to reject, but man, that really confuses some people. So for practical purposes, you do accept the null, that there's no relationship if your significance level is above 0.05. If your significance level is less, then you reject the null and you go with your alternate. Okay, I hope that helps you out. And if you have questions, of course, feel free to contact me and ask me to clarify.